Assalamualaikum warahmatullahi wabarakatuh. My name is Andi Muhammad Faisal Karim Suparman. I'm from Group 4. My material is the Pythagorean Problem. First, geometric proofs of the Pythagorean theorem. Although tradition is unanimous is ascribing the so-called Pythagorean theorem to the great teacher himself. We have seen that the Babylonians knew the result for certain specific triangle at least a millennium earlier. We recall the theorem as the area of the square built upon the hypotenuse of a right triangle is equal to the sum of the areas of the square upon the remaining sides. Because none of the various Greek writers who attributed the theorem to Pythagoras lived within few centuries of him, there is little convincing evidence to corroborate the general belief that the master, or even one of his immediate disciples, gave the RST rigorous proof of this characteristic property of right triangles. Moreover, the persistent legends that when Pythagoras had discovered the theorem, he sacrificed 100 oxen to the muses in gratitude for the inspiration appears an unlike story, because the Pythagorean ritual forbade any sacrifice in which blood was shed. What is certain is that the school Pythagoras founded did much to increase the interest in problem directly connected with the celebrated result that bears his name. Still more are we in doubt about what line of demonstration the Greek originally offered for the Pythagorean theorem. If the method of Book 2 of Euclid's Elements were used, it was probably a dissection type of proof similar to the following. A large square of side A plus B is divided in two smaller squares of sides A and B represented and two equal rectangles with sides A and B. Each of these two rectangles can be split into the equal right triangles by drawing the diagonal C. The four triangles can be arranged within another square of side A and B, as shown in the second figure. Now, the area of the same square can be represented in two ways: the sum of areas of two squares and two rectangles, and the sum of areas of a square and four triangles. When the four triangles are deducted from the larger square in each figure, the resulting areas are equal or equivalent. C equals A square plus B square. Therefore, the square on C is equal to the sum of the square on A and B. 2. Early solution of the Pythagorean equation. The geometrical discovery that the sides of a right triangle were connected by a law expansible in numbers led naturally to a corresponding arithmetical problem, which we shall call the Pythagorean problem. This problem, one of earliest problems in the theory of numbers, calls for all right triangles whose sides are of integral length. That is, all solution in the positive integer of the Pythagorean equation. A triple x, y, and z of positive integers satisfying this equation is said to be a Pythagorean triple. Ancient tradition attributes to Pythagoras himself a partial solution of the problem expressed by the numbers, where n greater than 1 is an arbitrary integer, as is perhaps more often the rule than the exception. In such instance, the attribution of the name may readily be questioned. 3. The crisis of incommensurable quantities. The most important achievement of the Pythagorean school in its UNC on the evolution of the number concept was the discovery of the irrational. The Pythagoreans felt intuitively that any two line segment had a common measure, that is to say, starting with two line segments, one should be able to some third segment, perhaps very small, that could be marked of a whole number of time on each of the given segments. From it would follow that the ratio of the length of the original line segments could be expressed as the ratio of integers or as a rational number. One can imagine the shattering effect of the discovery that there exists some ration that cannot be represented in terms of integers. Who it was that RST established this, or whether it was done by arithmetical or geometric methods, will probably remain a mystery forever. The oldest known proof that dealing with incommensurable line segments correspond in its essential to the modern proof then square root 2 is irrational. This is the proof of the incommensurable of the diagonal of a square with its side, and it is to be found in 10th book of Euclid's Elements, a reference in one of Aristotle's works. However, make it clear that the proof was no long before Euclid's time, and as in most classical demonstration, the method of argument was indirect. Thus, the negation of the desired conclusion is assumed, and a contradiction is derived from the assumption. For theon sides and diagonal numbers, theon of Sirsa 130 devised a producer for searching closer and closer approximation of square root 2 by rational numbers. The computation involved two quants of numbers, the sines number and the diagonal numbers. We begin with two numbers, one called the RST side and denoted by x1, and the other the RST diagonal and indicated by y1. The second side and diagonal x2 and y2 are reformed from the RST. The third side and diagonal x3 and y3 from the second, and so on, according to the scheme. In general, xn and yn are obtained from the previous pair of side and diagonal number by the formula. If we take x1 equals y1 equals 1 as the initial values, then the named side number and diagonal number hint that the quotients yn over xn of the associated pairs of this number come to approximate the ratio of the diagonal of a square to its side. The last, Eudoxus of Cnidos. The discovery of irrational numbers caused great consternation among the Pythagoreans, for it challenged the acquaintance of their philosophy that number was the essence of all things. This logical scandal encouraged them to maintain the pledge of strict secrets. Indeed, they resolve it is testified to by the very name given to these known entities, the unutterable. The Greeks used the terms logos, meaning word or speech, for the ratio of the two integers. Hence, when incommensurable lengths were described as a logos, the terms carried a double meaning, not a ratio, and not be spoken. The knowledge that irrational excited was a dangerous secret to possess. Popular legends has it that the RST Pythagorean to utter the unutterable to an outsider was murdered, thrown off a ship to drown. It fell to Eudoxus of Cnidos To resolve the crisis in the foundation of mathematics, great contribution was a reverse theory of proportion applicable to incommensurable as well as commensurable quantities. Everything was based on an elaborate definition of the ratio of magnitudes, but magnitudes themselves were left undefinied. Hence, the problem of dealing irrational numbers as numbers was avoided entirely. The immediate effect of Eudoxus' approach was to drive mathematics into the hands of the geometers. In the absence of a pure arithmetic theory of irrational, the primacy of the number concept was renounced. Geometry was held to be a more general doctrine than the science of numbers, and for the next 20 years itself and the basis of almost all rigorous mathematical reasoning. Thank you. Assalamualaikum warahmatullahi wabarakatuh.